Now in this video we'll see the configuration of bidirectional PIM. Now before we go ahead with the actual configuration, let me give the basic setup idea what I already configured here. I'm going to use the same fire routers like we used in our all multicast labs. Now the first thing, I got an OSPF pre-configured here with all the routers in area 0. And the second thing is I already enable IP PIM sparse mode on all the routers and all the current interfaces, whatever the interfaces you can see in the diagram. Now these two things are pre-configured in my lab. Now to further verify, I can go to router 2. If I give show IP PIM neighbors, if I give a command called show IP PIM neighbors, now you can see on the router 2 I got two neighbors, that is router 1 and router 3, and obviously the OSPF neighborship is also there because I already pre-configured that. Now similar way, if you check on the router 4 also, you got 3 PIM neighbors, and show IP OSPF neighbor, I got 3 routers, and everything is pre-configured. Here the OSPF and the PIM sparse mode is pre-configured. And the next thing what I'm going to do is I'm going to configure the router 3 loopback 0 as an RP, and also it is going to be configured as a mapping agent. So it's going to be my RP as well as the mapping agent, the loopback 0 interface. Now to make that possible, what I'm doing is the first thing I'll advertise that loopback interface inside my OSPF so that we can have reachability to that. And the next thing, I'm going to enable IP PIM sparse mode, and then I'm going to say IP PIM RP candidate. So I'm going to use the standard method of advertising the RP information, that is a BSR, and then it's going to be the same. The BSR router as well as the RP, it's going to be router 3. And then the next thing, I'm going to assume that I'm going to simulate some host which is going to join a group called 224.5.5.5 on the router 5, and we are going to simulate some server on the router 1. So the router 1 is sending some multicast traffic to the receiver which is on the router 5 for the multicast group of 224.5.5.5. Now to make that possible, we know that we are simulating a host by generating some join group commands for this particular group address, simulating a receiver. And then if I go to router 1 and if I try to ping, I should be able to reach to that multicast group address 224.5.5.5. If I'm able to reach, it confirms that there is a reachability. But here I'm not able to reach. Let me check 224.5.5.5. So let me do some troubleshooting. So I just need to ensure that all the interfaces are up here. Let me go and verify what is the problem here. Now if you just observe, I'm able to ping. I didn't do anything. It just takes some time to register themselves with the RP and to learn about that particular multicast traffic. Now once we configure the IP PIM sparse mode and we are going to configure some join group commands on the router 5, and we are simulating the traffic from the router 1. If you go to each and every router, if I give show IP mroute, probably you will see every router is going to build something called S-G entries, where according to the default sparse mode implementation what we have learned, the server is going to register with some PIM join messages, and it's going to build something called S-G entries, and all the receivers are going to send, the receiver router, the first hop router we can say, is going to send something called here it is register messages, and then the receivers are going to send some PIM join messages, and based on that they will build some *G entries from downstream towards the receiver, and then the receiver is going to learn about the source and it's going to build some shortest path to reach the server, and then it's going to build *G entry directly from server to receiver, the source to receiver. Now this is something default. What happens if you're enabling any kind of PIM sparse mode implementations? So initially it's going to build the route via RP, and then after that it's going to use the shortest path. Now if you're using bidirectional PIM, now the feature of the bidirectional PIM is it's going to build only *G entries, and it will not fall back to the S-G entries. So it's going to forward the multicast traffic always via RP. So that's what we have seen in theoretical topics in the previous PIM bidirectional feature. So we are going to practically verify the same Now to make that possible, the first thing we need to enable bidirectional PIM. Now the configuration of the bidirectional PIM is going to be very simple and straightforward. We need to enable this command IP PIM bidirectional enable on all the routers. That's the command. And then whichever the router we have configured as an RP. So it depends like which kind of RP configuration we are going to use. If you're using static RP, we need to enable the bidirectional feature on the RP routers. And if you're using auto RP, Cisco proprietary method, or if you're using BSR router, probably we need to enable bidirectional in the end. So in my scenario, I'm going to use the third one, that is the standard way of advertising the RP information. That's a bootstrap one. Now to make this possible, I'm going to enable this IP PIM bidirectional command on all the routers. IP PIM bidirectional enable. Let me copy paste the same command on all the routers, and the same thing on the router 2, and then on the router 3, router 4 as well as router 5. And finally, once we enable this command, all the routers will realize that they have to enable bidirectional PIM, which is an extension to the normal basic sparse mode implementation. Now only on the RP. Now in my scenario, I have configured the router 3 as an RP. So if you remember, we have already enabled this command IP PIM RP. So I'm just going to add bidirectional in the last. And if you verify the configurations, I should see the RP information is advertised along with the bidirectional feature. You can see this command. And for further verification, I should see only S, G, star, G entries, and there is no S, G entries. So to make sure that I should see them, just clear IP mroute command to refresh your mroute table. So because whenever you are testing any new configurations, I suggest you to go through with this command, which is going to clear the previous routes, S, G or star, G entries, and it's going to build the new ones. Now in my scenario, if I check show IP mroute, I should see, I don't see any star, G entries for this 224.555 because I did not generate any traffic. So let's generate some traffic for the group 224.5.5.5, and then I'm going to repeat multiple times. Now you can see I still have a reachability. That's a good thing, and which confirm that we have a reachability from the source to the receiver. And if I try to verify show IP mroute for 224.555, now here you'll see the star, G entries, which is build bidirectional PIM upstream towards S1 by 1 interface, and the outgoing interface is S1 by 1. Here you can see that's a bidirectional upstream sparse mode. And if I go to router 2 also, I should see the same thing. There's no S, G entries here. Now similar way, if you go and check on the remaining routers as well, let's go to router 3, and the same thing on the router 4, and you can see on the router 5 as well. Now there's no S, G entries, but still we have an end-to-end reachability here. Now here you can see if you are enabling the bidirectional PIM sparse mode, here, the only difference between the normal sparse mode and this one is there's no S, G entries built here. So it's going to simply remove this S, G entry, and all the traffic will flow upstream to the RP, and from the RP back down to the receiver. Now this bidirectional PIM is a more common implementation if you're going with many-to-many applications like video conferencing, where too many S, G entries is going to increase the processing overhead on the routers, and that is something we don't want. So we want to ensure that all the routers have something called star, G entries pointing towards the RP, and then the output interface list will be on the interfaces from where it is receiving the PIM join messages.